We will start in a couple of minutes. So today I want to go to get in more details with polynomial functions. Maybe start with the really basic one, and maybe some review of quadratic functions. So please scan the QR code. Make sure the link is correct. Okay. Okay. Let's start the session. Okay. We'll start from here. Okay. To remind you the inequality. Using the line number to solve the inequality. And I need to mention that last time, the questions is actually x squared minus x. Okay, this is the answer. I do some mistakes here. This should have square root if you want to have this answer. Okay. If there is no square root, then the answer is x is not equaling 0 and x is not equaling 1. Just some step back. Let's just go to our last page. Is this crazy situation here? Okay, this is just trying to exercises. Okay, exercise with the ability that you already know or learned before. You can actually solve this type of question. Okay, I will start with the polynomial functions, but let me draw some quadratic functions. Okay, I have in this point, okay, I have 2. In this point P, I have 2, 0, right? If the dash red color one is, let's say this is f of x, this is g of x, okay? If the red one is x squared, okay? If the red one is x squared, what is g? Squared, okay? So this is x minus 2 squared, right? Or I can rewrite this as my expansion, right? And from here, okay, maybe you have learned before in maybe high school or maybe junior high. So this p, okay, we called also in this positive squared. Okay, we call this is a minimum value. Right? If minus x squared, then it's like a mountain, and we call the maximum value. Okay? Just to remind you, so we call this a minimum value. Okay, so minimum value. Maybe you remember the expression. If this is A, B, C, okay, the minimum value is, okay. So this is because it's -4, I will cancel the negative. So 4 over 2, it's 2, and this is 2. Okay. And what is happening if I or maybe not 1, maybe 2. I have another graph here. Let's just say this is a similar graph, typical similar graph, and let's say this is h of x. Okay. So what is h of x? X minus 2 squared. Yeah, plus 2. Okay. Then your expansion will be x squared minus 4x. The same, just plus 2, right? Plus 6. Okay. The minimum value is still the same. This is 2, right? Because our b is -4. Okay. And from here is actually, you can see this 2 here, x minus 2. Okay. Actually, we can conclude, okay, if you see any expansion form and you want to prove that this is actually the minimum value, so I can rewrite my standard form. Let's just say f of x, okay, x minus, I'm not sure if it's h or k, maybe h. Okay, I think it's h, and then plus k. Okay. And this is precisely the same as when we did the when we try to solve this and prove the quadratic formula. Okay. You get x squared plus b over a, x plus c over a, right? Equals 0. And then you have, let me just write all the steps. Okay, and then you can continue writing down. So basically, the b over 2a here is actually our h here. So that's why when we are trying to find the minimum value, it's the negative value of our b over 2a. Okay, and this plus k is actually over our c over a. Okay, so you can also rewrite the any quadratic functions and find the minimum value or maximum value through h. Okay, so h will be x at min or max value. Depend on the situation on the x squared. So when you have x squared, this should be having a minimum value. When you have minus x squared, you will have a maximum value. Or you can say the a. Okay? The a is positive. This is a is negative. Or maybe a is greater than 0. Okay, this probably better. Okay, just a small review. Okay, about last quadratic functions we tried to prove. Okay. Okay. What I want to go for is more general polynomial functions. Okay. So let's start to have some notes. So polynomial functions. Let's just say the general is let's start with an, and then the next one. Okay, we can rewrite the general equation for polynomial. For example, if I just have my polynomial is only x with the power of n, okay, I can have my my functions. It can be x squared or x cubed or maybe x fourth, right? And if we divide, become two kind of function, odd function and even function. Let's start from 3. But remember, in polynomial, okay, uh, you learn about the degree of the functions. Okay, you learn the squared, cube, right? But we will not have our linear functions in polynomial. Okay, so one general requirements here is n should be greater than 1. Okay, this is important because linear is the behavior of the function is totally different from the degree when it's greater than 1. Okay, if we try to divide, become 2. Okay, 7. Maybe start from even from squared, 4, and then 6. Okay, if I draw some, let's just say the even function. This is the easiest one. Let's say the x squared, right? How would you describe the x to the fourth in the graph? This is x squared. How would you describe x to the fourth in the graph? For x squared, let's just say uh, we have some table here, 0, 1. If 1 is still 1, If 2 is 4, if 3 is 9, right? Okay. And what will happen if we change the functions to x to the 4th? This is 0, so 1, okay? And then how about 2? It's 16, right? 3, it's 81, and so on and so forth. If you see here, okay, 0 and 1, they are still having the same exact position, right? But when we increase our x into 2, for example, this is 0, 1, 2, 3. Okay. Maybe this is it's not really proportional, but let's say this is 4, okay? And 3 is 9 here. So around this, from 0 to 1, the x to the 4th is still the same graph as x squared. Okay, but when we are touching the uh, 2 and 3, it will be more. What will happen? I think it's more. Maybe 16 is here. And if we increase our value, it's still the same, 0, 1. But here will be 64. 64 is maybe around here. So maybe it's getting, how to say that? So you have quite wide at the beginning, and then you have shrinking in this horizontal, right? But you still have in 0 and 1 here is pretty much flattened, okay? The same thing happens when you are dealing with the odd function. When you increase the degree, it will be shrink in the x-axis, and it will be flattened in this area here. It will be flattened. And just to imagine what will happen with the graph. Okay. And then another point that is important in the polynomial, we will deal with the zeros. Okay. Or it's called the real zeros. Okay. Zeros mean, or real zeros mean, any number that makes px equal 0. Okay. So when you plug in that c, it will become 0. Okay. So p is polynomial. C is in real number. Okay. We can say that C is zeros of P, and we can conclude that the X is equal C. This is solution for Px equals 0. Okay. And we can say the X minus C is our factor. This is just a terms, and probably you already have done all these things, but this is just to make sure that the definition and the terms. Okay. And also C is intercept. The x-intercept of the polynomial. Okay. So in polynomial, you have zeros. Like just say the C is our zeros. So when we have the polynomial equaling 0, we want to solve. The solution will be x equals c, one of the solution, and then the x minus c will be the factor, and c itself is the x-intercept of the polynomial. I think this is quite very basic. I think you already done all of this thing. Okay. Okay, let's go a little bit about the. There's also the same theorem, okay, in calculus for continuous function, but in the polynomial there is also similar theorem and similar usage. Okay, so it's also called intermediate value theorem. Let me plug in the cable first. Okay, so the intermediate value theorem. So if P, okay, is a polynomial, let's just say a polynomial functions, and then PA and PB, okay, let me make some underline, have, okay, have opposite signs, then there exists at least one value of C between for Px equals 0. Okay, what does it mean? If I have a graph, let's just say the graph is from here. Let's just say that is our graph. Okay. And this is PA. This is P. Okay. So this is your interval. This is your interval here. Okay. In the middle of A and B interval. So the theorem say that when you have PA and PB in opposite signs, okay, so in this case, okay, in this illustration, this is negative, right? And this is positive. Okay. So whenever you have these conditions, there will be some number here, any number, okay, any number. Let's just say C number here. This C will make the polynomial 0. Okay, I think it's really good if you draw, and I think it's more clear instead of the words. Okay. Because sometimes words can be ambiguous, and it's not easy to understand. But graph, it will be more exact. That's why I think in engineering, most of departments, how they develop their method, most of the time graphs or visualization is, I think it will be more emphasized. Okay, so that's intermediate value theorem in polynomial. So you can also use the intermediate value theorem in polynomial to prove the zeros. Okay. In calculus, the value theorem, intermediate value theorem, it is for to prove that there is a number in between the interval if the function is continuous. Okay? If the function is continuous, if not continuous, then it will be broken, the theorem. Okay? So you need to make sure the continuous function. But of course, in basic math, most of the time the function is continuous. Okay, okay, so that's the intermediate value theorem. And then another thing is we can also using zeros to graph our function. For example, if I have my polynomial functions, okay, in a factor form, let's say the factor is x plus 2, okay, x minus 1, and then x minus 3. Okay, the solution, you can write x equal -2 and so on, or you can write zeros are, this is acceptable also, zeros are -2, 1, 3. You can write like this, or you can write x equal -2, x equal 1, x equal 2. It's the same. I'm just showing you some terms that personally, in my experience, I also never use these zeros, zeros, zeros. I always use x equal something. It's more exact, but this is another term that you can also use. Okay, so first we can start with using our line number and put uh, all the zeros into the line number, and then we can test the um, another number in between the interval or nearby the intervals. Let's start from the left. Okay, let's start from -3. If you plug in -3, it will be minus here, minus, right? So minus, minus, positive, and minus, and it will be negative, right? If we try 0 here, it will be positive, negative, negative, it's positive. Okay. Try 2 here, it will be positive, positive, negative. So it should be negative. Okay. And trying more than 3, it's positive, positive, and it is 0. It's 4, 4. It's positive. Yeah, all positive. So negative, positive, negative, positive. You can try to draw, or at least it's rough sketching. So maybe -3 is here, or maybe from this is 0. But because the function is easy to be counted, so you can also try to plug in the number and find where there's the y-axis. Okay. So the zeros are -2, 1, and 3. So this sign, okay, this sign negative, positive, negative, positive means in -2, it is changing from negative to positive, right? So maybe the graph will be around here, going up, right, until it's reaching the positive. And for the 1 here, it should be from positive to negative, so it should be around here, right? And for the 3, positive 3, is from the negative to positive, so maybe around here. And in between those changes, there will be maximum value maybe around here, minimum value around here, right? So this is just a rough sketching. And maybe you can check 0 and -1, which one is the max value. But because this is actually quite symmetrical here, maybe it's around in this between -1 and 0. Maybe around here. And this goes down, and maybe around here, and going up until maybe here. Okay. If you want to make sure, you can check the -3, maybe around this -1 and 0, which is what is the value, and then check the 4, maybe check here, check 2, what is the value here. Okay, that's more accurate, but at least from the negative, positive, negative, positive, you can predict the graph. Okay, what will the graphs look like? Okay. Okay. Another thing to note is it's called multiplicity. If C is zeros of P, okay, just say that P is polynomial. Okay. If C is a zero of P of multiplicity M, then we have first is if the function is odd, and the second is if the function is even. This is C. Or you can also have, this is also C. It should be the same one and you just mirror the image. Okay. And the second one here, C. And this is the last one. And the M should be greater than 1, M should be greater than 1. This is what I said before. We should not including the linear function. So we need to have more than 1. So at least 2, okay, for the even. And then for the odd, at least 3. Okay. Okay, so what does it mean, or what we can do for the multiplicity? So if you have a polynomial function, okay, uh, let's just say the polynomial function is, we have x with 4, x minus 2, 3, x plus 1 squared. This is also polynomial functions. And this 4, 3, and 2, this is our multiplicity, our m. Okay. So from this multiplicity, we can predict, like for example, we can predict how the graph will look like. Okay. Like I showed before, if you have maybe the even functions x squared, you compare with the x4, compare with the x to 6, x to the 8, and so forth and so on, you will see it will be more flattened in the 0 and 1, and then it's more thinner, okay, as the multiplicity goes up. Okay, and it can be also used for rough sketching for graphs. Okay. So back to this question here. Okay, let's just say that the zeros, okay, are 0, 2, and -1. Okay, but here, because it has multiplicity of 4, 3, and 2, we can write the 0 is zeros of m equal 4. Also the same thing, 2 is a zeros of m equal 3. -1 is zeros of m equal 2. So here is even, odd, and even. Okay. And same thing we did before. We can draw our graph. Let's just say this is 0, and this is maybe here -1, and this is 2. In -1, it's even. Okay, so it's going here. But between in -1 and 0, if we, oh, I forgot to write the line number. We need to write the line number first. So -1, 0, and 2. So before -1, let's say -2, if we plug in -2, it will be positive, right? Yeah, positive. Uh, Negative. Yeah, negative, negative, positive. And in between -1 and 0, we can try half. Is it positive or negative? The first one. Can you check? Greater than 2, it um, should be positive. 1, This is negative. How about half? Negative half should be positive, and then negative half, negative, it should be negative. Negative is half is positive. So positive, negative is negative. Right? Negative 2, it's positive. It's negative. Negative. Negative squared is positive. So, oh, it's negative. So what will happen? Okay, you have negative, but negative, negative, positive. So your intuitions, it should be crossing the negative 1, right? But it's still in this negative signs. Okay. And then the 0 also in negative sign. So from negative 1, 0, and maybe 1 here, it's all negative. And you see the 0 is also even. Okay. So it should be around. If this is here, maybe it's around here, even functions. Okay. And then for 2 is odd functions. So here it should be odd function. So maybe it's around here because it's going to be positive. Maybe it's around here. Maybe the graph will be looks like this. Maybe it will be here. Yeah. More or less, the graph will be looking like this. It's more. Okay. To make sure the graph is correct or no, or to make sure the point, you can check in between this point whether it's correct to some number here, and then you can correct the graph. Okay. So from this sign and from the multiplicity, you can predict how the graph looks like. So from the negative 1, you see here negative 1. Negative 1, it should be even. Okay. So if you ignore all of this, you should have like that one, right? But because when you have this function here at the function number between the negative 1 and 0, there is something here, okay, that makes the functions is going here because it should be if it is positive, then it should be crossing this line, right? But because it's also an even function, you have predicted, oh, it should be like this. Okay. But remember, okay, remember, this is just to remind you that in any polynomial, okay, the graph or the prediction of the graph, it's either that way, but you just need to mirror that image. Okay, it can be big, it can be small, but the shape, the characteristic, the behavior of all polynomial functions, the general polynomial functions, it should be similar, should be the same. So why I can draw like this one, because it's just polynomial function. It's not like exponent, it's not log, right? So every polynomial, the characteristic, the curves, the smoothness, it's all the same. Okay, it's all the same. Okay, so I think I will stop here until multiplicity. Maybe next time I will go for some notes for maximum and minimum value, and then go for maybe you still remember how to define the polynomials, okay? Dividing polynomials, okay? And then another rules for finding zeros is called the card rule. Okay, so that will be tomorrow session. So I will stop here. So the class is finished up until here, and yeah, see you tomorrow.